Well, good evening, everyone. I'm Don Bites. I'm a professor in animal science and biochemistry departments, and I'd like to welcome all of you to the 11th Annual Borlaug Lecture. It's so gratifying to see so many of you here tonight, and you have a wonderful presentation ahead of you. I'd like to tell you a little bit about the Borlaug Lecture. As I said, this is the 11th year, and it's been organized and sponsored by the Nutritional Science Council on the Iowa State campus, which is an interdepartmental program to coordinate activities of nutrition on the Iowa State campus. The program has financial support from the President's Office and the Colleges of Human Sciences, College of Agriculture and Life Sciences, and the Liberal Arts and Sciences. The lecture is named after the well-known Norman Borlaug, who is called, of course, by many affectionately the father of the Green Revolution. He received a Nobel Prize for his research career in 1970. And he has been the stimulus for the World Food Prize, which will be presented this Thursday evening at the State Capitol building. And all week could be called the World Food Prize Week. Unfortunately, Dr. Borlaug passed away in September of 2009. He pioneered research on developing high-yielding wheat that saved millions of people from starvation. Well, it's my distinct pleasure to introduce the president of Iowa State University, Dr. Stephen Leith, who will then introduce the speaker for the evening. Dr. Leith earned his BS degree at Penn State University and a Master's of Science degree from the University of Delaware, and then earned his PhD degree at the University of Illinois. He has worked at North Carolina State University with the USDA ARS system in North Carolina, and most recently was the vice president of the North Carolina University system. And he arrived on the Iowa State campus January 16th of this year and was formally installed as our president on September 14th this past month as our 15th president. Dr. Leith, thank you very much for being here, and we look forward to your introduction of our speaker for tonight. Thank you.
Good evening, folks. Great to see another big crowd for an evening lecture here at Iowa State. And I'm delighted to add my welcome to tonight's annual Norman Borlaug Lecture here at Iowa State University. It's one of our most prestigious lectures that we have during the year, and it makes us all proud to be at Iowa State. I especially want to welcome Ambassador Ken Quinn and his wife and other guests from the World Food Prize Foundation here tonight, so thank you for being with us tonight. They are great partners in this lecture series. Iowa State University is honored to be part of this tremendous celebration as to one of Iowa's best known and most important native sons, Dr. Norman Borlaug. We host this lecture, though, this week as part of a week-long celebration of the World Food Prize during World Food Prize Week, when the people of Iowa recognize the people who are leaders in the worldwide struggle against hunger and malnutrition. And tonight we're extremely honored to have this year's World Food Prize laureate as our Norman Borlaug lecturer. Dr. Borlaug was a giant in meeting the difficult challenges facing our world and providing sufficient food and other resources for its inhabitants. His incredible achievements and his deep and abiding passion for helping people gain the knowledge and tools they need to sustain themselves, their families, and their communities serve as an inspiration to all of us and a motivation for continuing his important work. I want to acknowledge and thank the organizers of tonight's lecture and poster competition. First, the Nutritional Sciences Council. Second, the Committee on Lectures funded by the government or the student body. As we've heard, the Colleges of Agriculture and Life Sciences, the Colleges of Human Sciences, and the College of Liberal Arts and Sciences. also the Plant Sciences Institute, the World Affairs Lecture Series, and the World Food Prize Foundation. So now I turn my attention to introducing our 2012 Norman Borlaug Lecturer. Dr. Daniel Hillel is the 2012 World Food Prize Laureate. He has devoted his life to helping agriculture make the most effective use of its most valuable and precious resource, water. Dr. Hillel pioneered the development of micro-irrigation, a technology that maximizes efficient water usage in agriculture, and this work has helped millions of people in the arid and semi-arid parts of the world increase their production of food. He was born in the United States and raised in Israel. Dr. Hillel was first drawn to the critical issue of agriculture and water scarcity during his days living in the highlands of the Negev Desert. His research led to the dramatic shift from the prevailing method of irrigation, which was applying large amounts of water in brief periodic episodes with flooding, followed by unnatural periods of drought to dry the soil back out. The new methods conceived and developed by Dr. Hillel applied water in small but in a continuous amount directly to plant roots, dramatically cutting the amount of water needed to nourish crops, maintaining their consistent health, and resulting in higher crop yields to feed more people. These water management concepts are now promoted by the UN Food and Agriculture Organization and are now used on more than 6 million hectares in 30 countries. One of Dr. Hillel's motivations has been to bridge divisions between nations and to promote peace and understanding in the Middle East by addressing a problem that so many countries there share in common, the scarcity of water. It is significant that his nomination for the World Food Prize contained letters of support from individuals and organizations in many countries, including Jordan, Egypt, and the United Arab Emirates. Dr. Hillel earned his BS from the University of Georgia, a master's degree from Rutgers University, and his PhD in soil physics and ecology from Hebrew University in Jerusalem. He has served as head of the Soil and Water Institute of Israel's Agricultural Research Service and as a professor at Hebrew University, the University of Massachusetts, and Columbia University. He has also worked with several international organizations, including the World Bank, United Nations Food and Agriculture Organization, the United States Agency for International Development, and he has been a consultant to government agencies in numerous countries. He is currently a senior research scientist at the NASA Goddard Institute for Space Studies at Columbia University Earth Institute in New York. He has received several awards and honorary degrees, and he is a fellow of the American Association for the Advancement of Science. Please join me in welcoming the 2012 World Food Prize Laureate, Dr. Daniel Hillel.
I'm awed by this honor that you've granted me, and I'm reminded only of one of the members of the Israeli parliament who asked for the right to speak, and the chairman, the Speaker of the House, said, "I confine you to 5 minutes." He said, "Fine, I accept. But before I begin, I'd like to say a few words." So what I would like to say is that it's an apocryphal story, but it follows upon the Bible, and we live by the Bible, the viable Bible in Israel. And the story has to do with what happened when the children of Israel left the house of bondage in Egypt and crossed the Reed Sea. And the Egyptian army was in hot pursuit, but the good Lord provided, and he parted the waters and allowed Moses to lead the children of Israel through the Reed Sea. And then when the Egyptian army attacked for the first time, but not the last, the waters were closed and the children of Israel were delivered. And after this great deliverance, they found themselves in the desert. Nothing but scorpions and snakes, and where to go. And the people besieged Moses. Moses, where do we go now? And Moses was very confused, but the good Lord saw his plight, and he bent down and said, Moses, where do you want me to lead the children of Israel? And Moses stammered, and he said, but there was no time to lose, and the decision had to be made. And the good Lord said, Israel, that is where I will take you. But some of us think that maybe Moses wanted to say, Iowa. And some of us think that we may have been paying for this historic mistake ever since. Anyhow, it's a pleasure to be here. And I'd like to pay tribute to a mentor of mine who was a professor at Iowa State, Don Kirkham, the late Don Kirkham, who was a pioneer in the study of soil physics. And I, among many other contemporary soil physicists, studied with him and his work. And so Iowa State is a power in the annals of soil physics. And we have colleagues here, and I don't want to embarrass them, but you are indeed a very important, very, very important campus. And so it is with some trepidation and awe that I deign to face you and say what is on my mind. Now, we shall talk about soil, water, energy, and ecosystems in a changing climate. You know, the world of science traditionally was divided between specialists and generalists. The specialists were those who studied more and more about less and less, and ultimately they would come to know everything about practically nothing. And the generalists were those who would study less and less about more and more, and ultimately they would know nothing about everything. And the answer is, of course, to this quandary, is that we have to study more and more about more and more. And so the study of science is becoming more difficult. We need to encompass not only the facts related to a given field or slice of science. We need to understand the larger context. We need to understand that all phenomena are interrelated. And it's becoming more difficult. And to do it, we need to cooperate. We need to learn how to communicate with one another effectively across disciplinary barriers. These are artificial. The world is an integrated entity, and we need to be able to broaden our view and deepen our view. And so it is in this spirit that I will attempt to describe some of the issues that are uppermost in my mind. And if time allows, and there will be some responses from you people, I will be very, very happy to learn from you. So, the topic is soil, water, energy, and ecosystems in a changing climate. Of the world's land area and soils, only some 25% are regarded as suitable for agriculture. This is different from the state of Iowa, which is largely agricultural. The remainder of the world has soils that are either too deep, or too steep, or too dry, or too wet, or unstable, rocky, cold, shallow, acidic, alkaline, or saline to permit the growing of crops. So the actual land under cultivation something less than 12% of the land area, is just about half the potentially cultivable area, with an additional quarter used for grazing livestock. And we are not able to expand agriculture much beyond where it is today without encroaching upon natural ecosystems and violating their biodiversity and impoverishing the world, the biosphere. And so we have to be very careful and learn how to intensify production and do it sustainably without degrading the resources of land and water and biota. So the practice of agriculture world over is not becoming easier. It's becoming more difficult, more exacting. And so what we bequeath to the following generation is a more complex world, a more complex view of the world, and a very great responsibility. At the core of the problem lies the inexorably increasing requirement of agricultural products due to rising populations, as well as to the universal desire to attain an ever higher standard of living. So consequently, our expansive population has been placing ever greater demands on the world's limited and vulnerable, I repeat, vulnerable soil, water, and biotic resources. At the beginning of the 18th century, just 3 centuries ago, the world's population totaled fewer than 600 million people. Since then, with infant mortality reduced and life expectancy prolonged, the population has increased more than tenfold in the course of about 2 centuries, give or take. Although the fertility rate in many countries has been diminishing, the momentum of population growth still continues due to the increased number of young people of fertile age and the prolonged life expectancy. World population is now projected to stabilize at about 9 billion to 10 billion by the 3rd decade of this century. But that is only a projection and not a certainty. Another important demographic trend affecting the environment is the changing pattern of human occupation and habitation, specifically the growth of urbanization. Until the start of the Industrial Revolution, about 2.5 centuries ago or 3 centuries ago, the majority of the workers were subsistent farmers who produced mainly for their own needs. Since that time, as farm work became increasingly mechanized, the portion of the workforce employed on the farm has declined drastically. In some of the industrialized countries, such as the United States, Europe, Japan, it has fallen below 3%. But those 3% are being supplied by numerous other professions, not directly, but certainly indirectly connected to the work of the farming community. The vaunted productivity of modern agriculture has its problematic side. Farmers, once largely self-sufficient, now rely on external industries for their inputs and tools, including fertilizers and pesticides and electricity and machines and fuel to operate all these. The intensive production of marketable farm products has induced a growing industrial dependency, requiring ever greater quantities of chemicals and energy inputs to boost fertility and to control pests and diseases. Accumulating residues of these chemicals tend to contaminate the larger environment, to pollute groundwater aquifers and surface waters, streams and lakes, as well as to decimate wildlife and threaten the health of domestic animals and humans. Large machines, operated conveniently and hence used excessively, perhaps, can cause direct damage to the soil, including compaction when wet and pulverization when dry, leading to accelerated erosion, in addition to damage to aquifers by overpumping, depletion, and pollution. The enormous increase in labor efficiency resulting from the use of motorized machinery has been purchased at the cost of greatly increased consumption of energy and reliance on external, unstable, and increasingly expensive energy sources. In some types of agriculture, the total amount of energy consumed in fuel used to operate engines and to produce and supply fertilizers and other inputs actually exceeds the energy value of the products. So while modern mechanized and chemicalized agriculture seems highly efficient from the point of view of human labor, it is in fact inefficient in terms of energy input versus output. The growing cost of fossil fuels and recognition of the negative environmental effects of their excessive consumption must induce a change in the mode of agriculture. Much of the energy used in agriculture, for example, in intensive tillage and irrigation, is commonly wasted. The current trend toward minimum tillage or even zero tillage is a positive development. So is the change from excessive flood irrigation to precision sprinkling or drip irrigation. Clearly, much more attention must be devoted to optimizing energy, water, nutrients, and pesticide inputs in agriculture so as to enhance economic efficiency and avoid environmental degradation. Agriculture, being the utilization of land, water, solar energy, and biota for human sustenance, is a fundamental aspect of our civilization upon which depends the quality of human life. If sustainable modes of soil and crop husbandry are further developed and more widely applied, agriculture should become less disruptive and more harmonious within the natural environment and its community of life. At the same time, land and water resources that had been degraded by past abuses should be withdrawn from further exploitation and rehabilitated. The concentration of population in urban communities and the funneling of products from extensive, sparsely populated hinterlands into densely populated centers have created new problems of transportation, distribution, energy use, waste disposal, as well as domestic and global climate impacts. As more and more people are moving into cities, the cities are expanding and usurping some of the best farmland. Worldwide, some 20 to 30 million hectares are being converted from farmland to urban uses annually at present. The process of urbanization has its environmental consequences within each city, as well as beyond it. Buildings and streets create impervious surfaces that generate a great volume of rainstorm runoff, which in turn carries pollutants, including oil leaked from automobiles and residues of various chemicals used in homes and businesses. Since some of these pollutants are not filtered through the soil, which is the natural living filter, they tend to persist in part and to drain into rivers and reservoirs and even into estuaries and bays and the open sea. The preponderance of asphalt, concrete, and glass and the paucity of actively transpiring vegetation in cities results in absorption and emission of heat, and consequently cities tend to be warmer by several degrees on average than the open countryside, a phenomenon known as the urban heat island. At the same time, motorized traffic and industries in cities cause the emission of much smoke and smog, causing gases that affect the radiation balance as well as public health. Wise city planning, therefore, allocates a goodly fraction of the urban expanse to open parks, tree-lined boulevards, and vegetated green roofs. Of the land area, constituting about 30% of the globe's surface, only about 11.8% is arable. However, that proportion varies from one country to another and from one continent to another. In the Ukraine, for example, about 50% of the land is arable. In the US, the fraction is about 19%, whereas in Egypt, it is less than 3%. Egypt is an interesting case in point. We have the statistics for Egypt. About 200 years ago, at the beginning of the 18th century, Napoleon invaded Egypt, and his purpose was to disrupt the British Empire and its connection to its crown colony in India, but that's of no interest to us anymore. That's past history. What is of interest to us, that he brought demographers with him, and they counted the population of Egypt. The population of Egypt at the beginning of the 18th century was 2.75 million. And from the best knowledge we have, based on the studies of archaeologists and historians, that was roughly the population of Egypt throughout the thousands of years of Egyptian civilization. It might have fluctuated up and down a bit, from 2 million to perhaps 3.5 million. What do you think the population of Egypt is today? Would anybody in the audience like to guess? Say again? 84 and climbing. Soon approaching 90. Perhaps in not very many years it'll be 100 million. And so here we are, a 30-fold or 40-fold increase in the course of just 2 centuries. And Egypt is not alone. I only gave that as an example. I do not want to single out Egypt. The population everywhere has been increasing. In many of the countries that cannot sustain such an increase in population, we must be very deeply concerned about that. So, the amount of arable land per capita has been diminishing. Diminishing because of the increase in population, but also because of the usurpation of land and the degradation of land and the expansion of urbanization. These are issues that are of great concern. Although the ongoing growth of population undoubtedly contributes to what is now acknowledged to be an environmental crisis, an even more important factor is the quality of human management of the open environment. Some of the most crowded countries in the world, for example, the Netherlands and Japan, have managed their environments with greater care, while others have not done so well. Profligate use of energy in industry, transportation, and domestic life, as well as carelessness in the use of materials and the disposal of wastes, characterize the hasty economic progress, quote unquote, the misuse of the term progress of some rapidly industrializing countries. The results are pollution of air, soil, and freshwater resources, and even of seas. Not the least of the consequences now recognized as global is that threat of climate change. We have increased the concentration of radiatively active gases. These are the gases that trap heat rather than allow its emission and the maintenance of a stable energy balance of the earth by some 50% or more. Carbon dioxide has increased from some 290 parts per million. It's now approaching 400 parts per million. Then there's methane and nitrous oxide and a host of other gases in the atmosphere in which we live, in which we breathe, that are changing the energy balance of the earth. The dilemma of striving to satisfy increasing demands in the face of limited and in some cases dwindling resources has worried many observers ever since the Reverend Thomas Robert Malthus published his essay on the principle of population in 1798. In it, he argued that population tends to increase faster than food supply, and that unless that increase is checked by moral restraint, it must inevitably lead to wars and to famine and disease. For a time, early in this past century, it seemed that Malthusian warnings were exaggerated, even wrong. In the last 3 or 4 decades of the 20th century and the beginning of the 21st century, food production grew faster than population in all the continents except Africa. That increase, dubbed the Green Revolution, and we heard this evening of the great and seminal contribution of Norman Borlaug to that important Green Revolution. That resulted from close cooperation between plant breeders and soil scientists. The plant breeders developed new varieties of grain crops, primarily wheat and rice, with higher yielding potential, which depended, however, on optimal conditions of soil, moisture, and nutrients. The latter were the contributions of soil and water scientists, whose research resulted in improved land management based on the optimal application of fertilizers, soil amendments, tillage, and irrigation. The great improvements of the last few decades, however, may not continue indefinitely. Although new methods of genetic engineering based on recombinant DNA and other innovations in biotechnology offer great promise, there are constraints to expanded production resulting from the fact that the most favorable soil and readily accessible water resources, that is to say, the easily tapped aquifers and the favorable sites for damming rivers, all these have been pretty much appropriated, and further expansion of the area under cultivation and further diversion of water flows can only be achieved at the cost of disrupting the remaining natural ecosystems. Much of the land yet unutilized is marginal in terms of its potential and highly vulnerable to degradation by such processes as erosion, compaction, organic matter and nutrient depletion, salination, desertification, and the loss of biodiversity. A major constraint to increasing production is the rising cost of fuel. mechanized agriculture is highly energy consumptive. Its increase in output per man-hour of labor has been achieved at the expense of much greater dependence on fuel-driven mechanization. When the cost-benefit ratio is calculated in terms of energy input versus output, the energy balance of modern agriculture is in some cases negative. It takes more energy input than we can obtain as output. With the rising costs of energy, that mode of agriculture may be unsustainable economically. Worse yet, the profligate use of fossil fuels has resulted in a significant and progressive increase in the concentration of those radiatively active gases that I mentioned before in the atmosphere, an effect that tends to raise the temperature and very possibly the frequency and severity of weather anomalies, that is, storms and droughts, that may diminish rather than enhance food security. Progressive global warming will also result in sea level rise, which may in turn cause waterlogging and inundation of currently productive coastal lands and aquifers. The one continent that has not participated fully in the Green Revolution is Africa. In 1967, the annual grain production there averaged about 180 kilograms per person, an amount regarded as barely adequate to sustain a healthy life. 2 decades later, instead of rising, the average production had fallen to about 120 kilograms per person, and it has hardly risen since. That dire situation is both a cause and a consequence of strife in a continent that is the original home of the human species. The problems of Africa are complex. Much of the continent is arid or semi-arid, with fragile soils that are extremely vulnerable to drought and to erosion. In parts of the continent that are relatively humid, that is in the central tropics, the soils are highly weathered, leached of nutrients, and affected by aluminum toxicity. Over large areas, the deep-rooted vegetation that had recycled nutrients from the lower layers of the soil and that had returned them to the surface zone, that vegetation has been cut and used for construction or burned for fuel, for heating, or for cooking. Thus, the soil has been deprived of its protective and self-restorative cover of deeply rooted vegetation, surface mulch, and organic residues. An effective method to restore soil fertility is the practice known as agroforestry, by which crops and trees are grown together. Fast-growing, nitrogen-fixing, that is, leguminous trees and shrubs can be planted in parallel rows, preferably on the contour, with crops grown in between. The trees act as nutrient pumps, improving soil fertility and providing forage as well as firewood, while the crops grown between those rows provide food for subsistence and local marketing. In some cases, the tree rows are cut down every few years for timber and fuel, and their strips rotated with alternating cropping strips. So there are ways of improving management, and they need to be encouraged and incentivized. Much more can be done to improve the efficient and sustainable utilization of soil and water resources, both in rain-fed and in irrigated farming. Modern methods of low-volume, high-frequency irrigation can be applied to smallholder farms using inexpensive, locally fabricated equipment. Investments are needed, however, in the application of science to the enhancement of food production while protecting the environment and helping to mitigate the portending change of climate. We need to apply much more attention to these problem areas in the world. There's an old adage concerning the difference between the clever and the wise. The clever are those who are able to extricate themselves from situations that the wise would have foreseen and avoided from the outset. Now, however, it seems that our short-sighted cleverness as a species has gotten us into a situation, into a quandary, that mere cleverness can no longer resolve. Wisdom is now needed more than ever before, and the wisdom we need can only be developed through interdisciplinary research and active international cooperation in the protection and in the judicious utilization of our shared environment and its vulnerable resources. The ultimate purpose of environmental activity should be to ensure that each generation bequeath to its successors a world that has the full range of natural wealth, enhanced insofar as possible, and the full richness of human potentialities that it had received from its predecessors. That range encompasses the land, its soils, its waters, its atmosphere, its energy resources, its raw materials, as well as its multifarious and synergistic forms of life. Present yields in many areas are much, much below the proven potential yields. Where they can be enhanced substantially, there should be no need to claim new land and to encroach further upon natural habitats and their biodiversity. The possibilities for developing intensive, efficient, and sustainable agriculture can obviate the need for widespread cultivation and grazing of marginal lands, thus allowing natural habitats to regenerate. I can give a specific example from Israel. The average yield measured by various criteria in Israel has increased tenfold in the course of the last 2 generations since the establishment of the State of Israel. And that's only an example. There is nothing unique about that except the diligence and the education and the research and the application that took place in that country, and it can be done everywhere and must be done everywhere. Now I'll say something about a warming world and the dilemma of population and food. The world's population already, as I said before, exceeds 7 billion and is expected to reach 9 billion by mid-century. The task of providing sufficient food for humanity is increasingly constrained by land degradation, water resource depletion, and shortages of fossil fuel energy resources, and the inefficient use of energy resources. A problem foreseen by some but ignored by many until recently is that human-induced climate change is upon us. Ever since the Industrial Revolution began 2 centuries ago, humans have progressively been changing the climate in which we live together with all the biota and in which we raise our crops and livestock. And I explained before how we have been doing this by spewing out these heat-trapping gases Agricultural productivity and efficiency can and must be made sustainable. We can and must achieve this by reducing waste and improving resource and energy use efficiency all along the chain of food production. Processing, storage, distribution, marketing, consumption, and waste recycling, while ensuring food security and maintaining environmental quality. The principal challenge of our time is to achieve harmony between the responsibilities and the needs of developed and developing countries, between the needs of our generation and those of future generations, and between human species as a whole and other species in the community of life on Earth, the interdependent community of life on Earth. Ecology teaches us that each member of a community is defined not by its individual traits alone, but by the nature of its reciprocal relationships with other sharers of the same domain. The ancient tribal vision of the world is still deeply ingrained in us. We think only of ourselves and our group, and we tend to ignore. It's a human trait, all too human. The ancient tribal vision of the world is still deeply ingrained in us, as I said. Gradually, however, our vision has evolved, and our notion of kinship has extended to include first our immediate clan or tribe, then successively our village, our city, our country, our nation, and eventually all of humanity. And this expanded kinship perception and allegiance must now transcend the bounds of the human species and extend to the totality and the mutuality of life on planet Earth. In the powerfully symbolic vision of Genesis, the 2nd chapter and the 15th verse of Genesis, it says, "The Lord God placed the human earthling," that is Adam and Eve. Adam means literally earthling. It is a derivative of the Hebrew word Adamah, meaning the earth. And Eve, or Chava as she's pronounced in Hebrew, means life-giving. So Adam and Eve together mean soil and life, quite literally. So the Lord God placed the human species, the earthling, in the garden of delight. That is the Garden of Eden. Eden means delight. To serve and preserve. The King James Version says to dress it and keep it. But the real translation, the literal translation, is to serve and preserve its living community. When Adam and Eve, in the story, betrayed that responsibility by consuming in excess of need, they despoiled the Garden of Delight, and in so doing banished themselves, in effect, from its security and comfort. On a larger scale, the biosphere can be our collective Eden, if only we can serve and preserve the sustainability of its functions and of its living community now and into the future. I thank you.
There's time for a few questions, if anybody has any. Our speaker will take a couple.
Better yet, if there are any answers.
I like it that you've spoken to us about soil, water, energy, and in a changing climate, or I'll just say climate. And you've brought forth the interdependence, the interrelationships quite well. My question is that it's most people have an understanding of the importance of water, of air, and we know something about land, something about crop production, but most people don't, in my opinion, don't appreciate the importance of the component soil. And my question is, what could we do? What can we do as Iowa State University, as a group of soil science people that have an understanding of soil, to better communicate the importance and the role of soil in this relationship?
Thank you for this question. Bob Horton is a very good colleague of mine. We share a vocation and an avocation and an interest and a sense of mission. And I think the answer is in us, Bob. It's in our ability to reach out rather than crawl into our little comfort zone and make do with experiments and a few publications and a few students. It's for us to reach out into the larger community and convey the message that the soil is the central link in the chain of domains and processes that sustain life, that generate life and sustain life. So, I enlist you as you enlist me in this great challenge, this great task. And thank you for the question, and I think implied in your question was the same answer. Any other challenging questions that I may or may not be able to answer, but I'll try.
Yes, Dr. Hylil. I understand you're quite concerned about mechanized agriculture and its implications, but I'll ask you, what alternatives do we have to get the production we need in a world economy?
I'm only concerned about the inefficiency of some mechanized practices. I'm not against mechanization. I advocate making it more efficient. I'll give you one example. Not very long ago, the practice of soil tillage unnecessarily loosened the soil to great depth, turned it over. And we've learned that it is possible to plant and to sustain crops with minimum tillage, sometimes even with zero tillage. And that by excessively pulverizing the soil, we're actually making it more vulnerable to erosion, and we're destroying the inherent natural good structure of the soil. So I'm not against mechanization, but I'm for applying it more judiciously, more carefully, more sustainably. That's the answer. And in the process, making energy use much more efficient. By the way,
go ahead.
Okay.
We'll make this the last one, but go ahead, sir.
Go ahead.
Some context, how you came to that invention, and
Well, I'll give you the example that was developed largely in Israel by the community of soil and water scientists, and I participated in it. I do not claim any kind of exclusivity, but I took part in the development of more efficient methods of irrigation. Because water is so scarce in Israel, it's an arid country. And thanks to the fact that the Israeli farming community was not tradition-bound, that it was new to the practice of irrigation and was willing to try new ways, how to apply water more efficiently instead of flooding the land, saturating the soil, imitating the ways of the riverine valleys of the ancient Near East, that is Mesopotamia and Egypt, in which periodically or seasonally they saturated the soil and then depended on the extraction of the water from the soil by crops, hoping that before the plants begin to wilt, there will be another flooding. And the irrigation methods developed in the American West actually imitated that system by diverting water from streams, building dams to store water, and then leading the water through channels to fields in sequence by flooding the land or applying the water through furrows. That old method of infrequent, high-volume irrigation. And there developed a theory that soil moisture is equally available between what was called field capacity and wilting point, allowing the plants to extract moisture until they are just practically ready to wilt, and then applying the water once again. So it's large volume, low frequency irrigation. That was the prevailing mode of irrigation in many places. And then we discovered that the very opposite will produce better results. Instead of it's comparable to taking a baby and force-feeding a baby once a week with a tremendous amount of food, and then letting the baby lie down for a week before once again prying open its mouth and force-feeding it again. We find that spoon-feeding a baby slowly in response to need, slowly, almost continuously, is much more effective. And it saves a lot of water. It prevents the soil from being saturated, because when the soil is saturated, it is deprived of air. And plant roots need to respire, just as we need to respire. Plant roots, as well as leaves and stems, need to respire. So the soil should be well aerated. So by applying water little by little, we can not only improve plant growth, but improve yield per unit amount of water applied dramatically, double, treble it. So, and that was a great revolution. It seems obvious now in retrospect, but it didn't seem obvious at first. And as I said, what made it possible for Israelis, in a paradoxical sense, was the fact that they were not practiced farmers. They were not traditional farmers who learned the method of farming from their parents and from their grandparents, that they came afresh into a situation and were able and willing to question traditional ways. The same way, or in a similar way, we have to examine all of the premises and re-examine them and see how to make things more efficient. Another example is tillage. Until not very many decades ago, the practice was deep plowing and churning and then harrowing and re-harrowing the soil. And then the idea came in of minimum tillage, or even zero tillage in many cases, is much more efficient. It saves not only energy, but it also preserves the structure and the integrity of the soil. Questioning the old ways, finding better ways, more efficient ways, that is the charge of our generation, not my generation anymore. I stand before you 82 years of age and practically decrepit. But our students and our students' students, and you as a young person, have a great opportunity and a great challenge to do things better. Thank you for the question.
Let's stay up here then. We have one short part of the program to come, but before we get to that, on behalf of Iowa State University, I want to present tonight's Borlaug lecturer, Dr. Daniel Hillel, with a special commemorative plate honoring him as tonight's speaker. Surrounding the plate is a quote from Dr. Borlaug. John, would you please come forward?
Thank you, President Leith, and we have a small, exciting part of the program remaining. Thank you, Dr. Hillel, for your wonderful presentation. As many of you know, we had a poster session prior to tonight's lecture where students had the opportunity to share with you some of their research that has significance for international nutrition or feeding the world. Some of the students were undergraduates, some were graduate students. And the students participated in a poster contest in which their poster and their defense of their poster was judged by a committee. I'd like to thank publicly Dr. James Hollis and Dr. Helen Jensen for their part in tonight's program and in the poster contest, and the judges who participated in the poster session. Now I wish to recognize those 6 students who presented and defended winning posters. And I'd like to maybe call all 6 of you up here at once, and then we'll present you with your award. So would these 6 students please come up toward the front of the room by the stage. Michelle Richardson, Orlin Clark, Brittany Jurgemeyer, Jay Johnson, Yong Zhu, and Seth Armaugh. Okay. So Dr. Hillel and President Leith will congratulate our winners. 3rd place, undergraduate student, presented research poster, goes to Brittany Jurgemeyer. Brittany? Second prize goes to Orlin Clark. And first prize goes to Michelle Richardson. Now for the graduate students in the poster competition. Third prize, Seth Arma. Seth? Congratulations. Second prize goes to Yang Zhu. Yang? Congratulations. And first prize goes to Jay Johnson. Way to go, Jay. Wonderful. Well, thank you. That concludes our poster presentation awards. That concludes our activities for the evening. I'd like to thank you all for coming. And if you'd like to visit further with our speaker for the evening, please come forward and he would be happy to visit with you, I'm sure. So good night to everyone.